Welcome to this video on the topic of graphing functions. In this video, we're going to have a look at how we can graph hyperbolas that contain transformations. Hyperbolas may be easily graphed when in the form y equals c plus k over ax minus h. The reason for this is this form over here reveals three key attributes that allow us to easily graph it. Those being the vertical asymptote, the horizontal asymptote, and finally the reciprocal function. Looking at how we can get these three attributes, let's start with the vertical asymptote. The vertical asymptote is acquired by looking at the fractional part of the function here, and then we look at the denominator. The vertical asymptote can be found by observing the denominator and asking the question, what value of x will cause the denominator here to equal 0? The way in which we do this is we simply say x equals, and we know that to be able to get a value of x that will make this equal 0 is we simply go h over a. So if we subbed in h over a into this, well, firstly the a's would cancel and you just have h, and it'll become h minus h, which is 0, which is the location of our vertical asymptote. So x equals h over a. Next, we're going to turn our attention to the horizontal asymptote. The horizontal asymptote is found by looking at the constant within this function here. In this case, we're looking at c. So to be able to define the vertical asymptote, horizontal asymptote, we say y equals c. Those are our two asymptotes. Now let's turn our attention to the reciprocal function. The reciprocal function is found by first looking at the fractional component over here, and then finally looking at the constant over here. Firstly, looking at the fractional part, what we're going to do is we're going to say our reciprocal function is y equals, and I'm simply going to write out the fractional part but flip it. So I'm going to say ax minus h over k. Next, I turn my attention to the part that was the constant, and I'm simply going to say plus c. And what we have over here is our reciprocal function. Now this can be rearranged into slope-intercept form by some clever rearrangement, so I'm just going to say a over k, and that will be the gradient. And then we're going to have the constant part, which is going to be c take h over k. So this is slope-intercept form. Using these three key pieces of information here, we're able to easily graph this hyperbola. Let's have a look by example. We have the function f, which transforms x into 5x plus 12 all over x plus 2. We want to be able to graph this. Now, first problem we have is we notice that this is not in this general form over here. So what we're going to do is we're going to use the partial fractions method to turn this into this form, after which we'll be able to get these three key features. First thing we're going to do is we'll write this out as y equals. So y equals 5x plus 12 over x plus 2. Now next step is we want to be able to break this down. So I want to say, I look at my x's up top and I say I've got 5 lots of these, but downstairs I've only got 1. So what I want to do is I want to say 5 taken out, and then I'll say x plus 2, because that's my denominator here. Next, I've got the plus 12 still left over. Now if I leave it like this, then the expression has been changed because I've given myself 5 lots of 2. So because I don't want to change the expression, if I've given myself 5 lots of 2, I also have to take 5 lots of 2. Finishing this off, it's all over x plus 2. Okay, so cosmetically I've changed this. It looks like I've made it worse, but trust me, I've made it a little bit better if we observe the next step. This next step down, we can simply get this part over here and this part and write it together, and then this part and this part on a different fraction. So we're going to have 5x plus 2 over x plus 2 plus then we're going to have our plus 12, take our 5 2's are 10, so that's over x plus 2. Next, on the left fraction, we can cancel out the x plus 2's, which leaves us with 5 plus, and then if I simplify this over here, it's 12 take 10, which is 2, over x plus 2. And hence, using partial fractions, we are able to transform this over here into this general form over here, which allows us to easily gain the features or find the features of our hyperbola. Next, let us determine the asymptotes and the reciprocal function. Firstly, the vertical asymptote. This is going to be found by looking at the denominator in our fractional part, and we ask ourselves, when does, or for what value of x will cause the denominator to equal 0? It will be when x is equal to minus 2. So this is our vertical asymptote here. After which we find our horizontal. That's going to be based on our constant over here, so the 5. So we say y equals 5. Next, we find our reciprocal function. This is going to be defined as y equals something. We first turn our attention to the fractional component, and we're going to inverse it. So it's x plus 2 over 2. After which we look at the constant, which is the plus 5, and we simply give it 5. Simplifying this out, or putting it in slope-intercept form, I'm going to get a half x plus 2 over 2 is 1, so I'm going to get plus 6. So this is our reciprocal function here. Now, having a look at the graphing of this, I'm going to use Desmos. So I say up we come, and I've already plugged in the function here. Now, as a sneak peek, I can turn it on, and this is what our function will look like. But let's have a look at how we build this up. First thing we're going to do is we're going to put in our asymptotes. In this case, we're going to type in x equals minus 2, and then y equals 5. So here are our two asymptotes, 1 and 1. Now, because they're asymptotes, when I draw them, I should do them as a dotted line or a dashed line, just like that. So this is our vertical, this is our horizontal. Next, let's put in our reciprocal function. In this case, it's going to be y equals 1 over 2, x plus 6. Here's our reciprocal function. Now, the reason why we graph these is that we know that when we graph this function over here, so our f of x, what we're going to find is, because we have positive x, we're going to get a function that's going to be around here. It's going to go down and to the right. It's like graphing a hyperbola that's a simple one, like k over x. So it will look like that shape, but with the transformation. So here and here. So if I turn this function on here, what you can see is that our hyperbola fits nicely to the guides that we did, those being our vertical and horizontal asymptotes and our reciprocal function here. So we simply graph this, or we predict the shape of this hyperbola by using the asymptotes and the reciprocal function. Alright, let's do another example. We have b. F is the function that transforms x into 4x take 3 over 2x take 1. So this one's got a little bit more going on. Again, the way in which we're going to graph this is, firstly, we're going to put it in a standard form to find the vertical and horizontal asymptotes, followed by the reciprocal function. So I'm going to say y equals 2x take 1, and that's underneath 4x take 3. Now, next question I'm going to ask is, if I've got a 4 here, I want to change it in such a way that I'm going to be able to pull out or have a factor of 2 here. So I know I can say, let's go 2 by 2x take 3, and then 2x take 1. Alright? Now we know that we're going to have 2 here, and we've got a 2x here, so we want to put a -1 in here. So we'll say 2x take 1, and then because I've got to take 1 here, I've got to go, I'll put the +1 there to show it. Okay, next line, what I'm going to do is I'm going to remove this +1 from the brackets by multiplying it by 2. So therefore we get the bracket over here that's common with the denominator. So we'll go 2 times 2x take 1, plus 2 times 1 is 2, take 3. There we go. 2x take 1. So again, it looks like I've changed the value, but I've only changed the cosmetic appearance. So I had 2x in here, then to transform it with a -1, I simply took 1 and then gave it 1. So I plus and I minus, so it's really still just 0 there. And then I transform it again by multiplying the +1 by 2 to bring it out. Next, I put this in a more general form. So the x's go in this form over here and the constants on the right. The reason I do this is because I can cancel the constants like that, and then I'll just simplify the constant here. So I get 2 plus 2x take 1 all over, and this will be -1. Alright, easy. So this is our general form here. From this we can determine our asymptotes. So I'll go vertical asymptote in this case is going to be y equals, x equals, and then it will be 2 under 1, or more formally said 1 over 2. The horizontal is going to be the constant over here, which is y equals 2, and then the reciprocal will simply be the inverse of the fractional component. So 2x take 1 all over -1 plus the vertical asymptote, or the horizontal asymptote, which is +2. And I can put this in slope-intercept form by going -2x plus 1 plus 2 minus 2x plus 3. Perfect. So I can graph this by firstly graphing the vertical and horizontal asymptotes, then I will graph the reciprocal function, and then I will match a hyperbola around these features. So I'll say up we come to my graph, go to a new graph. I've turned off the grid here because I don't really like the grid. Okay, putting in the features. The vertical asymptote is at 1 over 2. The horizontal one is at y equals 2, and the reciprocal function is at y equals -2x plus 3. These are all like asymptotes. So what I'm going to do is I'm going to make sure that they're dotted lines. Now looking at what I have, usually my hyperbolas on the right over here and the bottom left over here, but you can see that the vertical and the horizontal asymptotes show me guides of like break down the quadrants, but if you look at the reciprocal function, it's in the top left and the bottom right. So what this describes to me is that my hyperbola is going to start in the top left up here, go down and go like that, so following my cursor, and then it will be over here as well. So they show me a guide of where to expect my hyperbola to appear. Now putting my hyperbola in, I go for the original function, which is 4x take 3 over 2x minus 1. And lo and behold, here is my hyperbola fit to the guides that I got over here. So my vertical asymptote, horizontal asymptote, and my reciprocal function. As you'll notice, the intersection between the hyperbola and the reciprocal function are some nice values, so 0, 3, 1 and 1. If you have a graphics calculator, you can easily compute these. Okay, so in summary, what we set out to do in this video was, firstly, we wanted to have a look at are the general form of a hyperbola, so the way in which we can write it, so we can get our three key features for graphing with transformations, so the vertical, horizontal asymptotes, and then the reciprocal function. This is found by making sure our hyperbola is in the form c plus k over ax minus h. And then secondly, using the examples, we had a look at how we can arrange the functions over here in this general form over here, using our partial functions. Finally, we used Desmos to see how we can use these guides over here to fit the hyperbola curve to the guides.